Hi, in this video we're going to be talking about similarity in triangles, particularly how we can shortcut this idea of similarity. Now, normally for things to be similar, we have to check all the angles, make sure that they match up, and the sides have to be proportionate. With triangles, though, we could do that, or we have these three little shortcuts that save us some time. We could, if we just get that proportionate part, then, hey, guess what? All the angles have to be congruent if we are just proportional. If we get just a pair of angles, so 1 and 3 are congruent, 2 and 4 are congruent, then we didn't check all the angles, but I know the sides will already be proportionate according to this angle-angle similarity postulate. You could also do this one. This one's the trickiest one, side angle side. So we've got a pair of sides that are proportionate, and we have the angle that's in between those given sides. So 1 and 2. If we had done it with like these two sides and these two sides and then this angle up top, then we wouldn't be able to use this side angle side. The idea is that it kind of like moves its way around the triangle. But using those, we can quickly determine if the triangles are similar. So let's try it out. In this diagram, I've got two triangles that are kind of like sitting on top of each other. And one way I like to deal with ones like this is actually break it up into the two triangles so I can see what's going on in each one. I've got this little triangle down here on the bottom, which has got this side of 90, that right angle, and 110. And then I've got the bigger triangle that's kind of going all the way over here. So this bigger triangle, it's got a right angle. I don't know what this distance is up top there, but I do know that this side is 90 and another 90. So 90 plus 90, this side should be 180. Now, once I make those two triangles, one thing I can note is right here, both the big triangle and the little triangle are using that same angle inside of there. So I can say that these two angles have to be congruent because they're referring to the same angle right here. This means I could use angle, 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 angle in order to say that these two triangles are similar. So I don't know why I drew a triangle. Angle, angle makes those two similar. Since they are similar, I can say that these sides have to be proportionate with each other. So I want to try to solve for this x. So I'm going to put that down first. X is matching with that 110 because that's the two that are touching that 90. 110. And the 180 and the 90 are in between the 90 and the angle that I marked. So those two also have to be paired up. I want to make sure that I'm keeping big on top and small on the bottom because that's what I did on that first one. So now I just need to solve this proportion. Well, that's easy to do. All I got to do is multiply both sides by 110. So x is going to equal 180 times 110 divided by 90. So I can just type that into my calculator and see what I get. That gives me 220 yards. Great. On this next example, I want to do that same process. I've got this little triangle up top. So that little triangle on the top has got a side of 5 and a side of 4. And then I've got this big overarching triangle. And that's got a 15 on the bottom. And if I go up this side, note that I've got this x and the 4. So this side right here has got to be x plus 4. Now, if I think about the angles that match up, both of them are using this angle up top here. So I know that those two angles have to be the same. But I don't know anything else in terms of sides. But what I do know, if I think back to my corresponding angles postulate, if I've got a set of parallel lines cut by a transversal. Here are my two parallel lines. Here is my transversal. These two angles are in corresponding spots. So those two angles have to be congruent. So these two angles have to be congruent. So I can use angle again in order to say that these two triangles have to be similar. Since they are similar, I want to solve for this x right here. I like to write that down first, so x plus 4. So that matches with this side because they're both in between those angles that I marked. And then these two are kind of both on like that bottom part right after the double angle. I want to make sure I keep big to small because this one was big to small, big to small. Okay. So then in order to get x by itself, my first thing I want to do is get rid of this divide by 4. So I'm going to multiply both sides by 4. So I get x plus 4 equals 15 times 4 is 60 divided by 5. Oh, I can do 60 divided by 5. So x plus 4 equals 12. And then I can just subtract 4 from both sides, and I get my x to equal 8. Let's try a few more, just identifying that theorem that makes these things similar or not. If I look at this diagram, I've already got an angle that's being marked. And so if I could find another angle that is congruent between those two triangles, I can say that they are similar. Now, what I'm interested in is these angles right here. I can say that these two angles are congruent because they are vertical angles. Vertical angles are congruent. So since those are congruent, we can say that these two triangles are similar because we found two angles that were congruent. So we can say using our angle postulate, but I'm just going to go angle. Since they are similar, I want to write a similarity statement. So I'm going to say that triangle is similar to other triangle. I want to make sure that, okay, I marked this one and this one. So those two, I'm just going to start with. So R and P, they have to be in the same relative spot. Then I've got this angle here. It's R and M on this direction and P and Q in the other direction, but really it's just N 2 times. And then I've got this final one. So R and M and P and Q. In this one, I don't know anything about the angles, so I can't use angle. I can't use side. But if I can show that all the sides are proportionate, then I should be able to say that this thing is similar. So let's just try them one by one. So I'm going to do the smallest one first. So 10, then 12, then 14. So these are all from my small triangle. These all need to be equal if we pair them up with the smallest to biggest over here. So 15 is my smallest, then 18 is the next size up, and then 21 is the biggest. So I want to see if all of these ratios are the same. Well, this first one, I can divide top and bottom by 5, and so that gets me 2 over 3. If I check the next one, I can divide both of these by 6. 12 divided by 6 is, hey, that's the same 2 over 3. If I can get that one more time, I'm going to be good. Let's see, 14 divided by 21. Yes, I could divide those both by 7, and I get 2 over 3. Again, hey, since all of these are the same, we can say that these are similar. And this time we used the side theorem in order to show that those two were similar. For our similarity statement, we've got one triangle and another triangle. Oh, not equals. I just want one squiggle. When I wrote my proportions, I'm going to actually kind of keep that same pattern of smallest side, medium side, biggest side, because then I can make sure that all the sides match up between our two triangles. So I went small, then medium, then biggest. So I'm going to go R QP for this triangle. And I'm going to do the same thing here, small, medium, biggest. So CBA. We want to make sure that the corresponding sides here match up with the ratios that are over there. In this example, I've already broken up into the two parts. I haven't done this part yet. So I've got APJ up top. If I look at this side, this is our AB, so 5 and 3. That's going to give me a side of 8. And if I check this side over here, I got 2 plus 3 and a third. I'm not a big fan of that mixed number, so I'll just keep it 5 and a third for now. If I think about congruence, A has got to be the same angle in both of these. So I could check using side, angle, side. If that's true, then I should get a similar triangle. Now I could use side, side, side on this one too if I wanted. Doesn't matter which one you choose, but I haven't done side, angle, side yet in this video, so that is the one I'm going to use. Now, when checking side angle side, it is important that if I'm using this angle right here, that I need to use the two sides that are on either side of that angle. Yes, I've got the same numbers down here, but it's important that I'm not actually using them in case these were different values than this side right here, because I want side angle side as I'm kind of like working my way around the triangle. So let's see. I think the most sensible way, I'm going to go this way. So 3 over 8. I need to see if that is the same as 2 over 5/3. Now, like I said, I'm not a fan of these mixed numbers, and it's kind of making it complicated to work in this thing. So I'm actually going to change this. To fix up that mixed number, we got to make that into 16/3. 2 over 16/3. And then in this fraction, in order to try to simplify it, I need to get rid of this divide by 3 in the denominator. So I'm going to multiply top and bottom by 3. So that gets us 6 over 16. And then this could be also simplified, so I can divide it by 2. And we get 3/8. And since this is equal to this, we can use our side angle side in order to say these two are similar. Using side angle side. Making our similarity statement, we could say that triangle. I want to make sure that A stays in the middle for both of these. So I'm just going to write that right away in the middle. And then let's go along PAJ and BAC. We could do it in other directions, doesn't matter. But we want to make sure that the corresponding parts are in the same relative spot. In this next one, we already have that nice angle being congruent. Since these are both 90, we should be able to just quickly check if this is going to be similar. So I'm going to go 6 and 10, doing the small one first and the big one second. 6, 10, and then 3, 4. So small first and then big second. So then if I simplify this, 6 divided by 3, that's going to be 2. And 10 divided by 4, oh no. 10 divided by 4 is 2.5. That's not true. So if this had been the same, then I could have used side angle side. So these are not similar. They are not similar, and we've actually already explained with our calculations why. Because these two are not the same. Since those are not the same, then these two cannot be similar. And that is it for our video on similar triangles. Reminder, you can either check with angle, angle, side, side, side. If you do side, angle, side, make sure you're moving in a clockwise or counterclockwise around the triangle to make that selection. And once you've found that, then you know that all the angles are congruent and the sides have to be proportionate. Thanks for watching. Bye-bye.